is example 3 from our circles lesson. Very similar to the last example we did, number 2. Find the center and radius. Well, again, this equation is in general form. It does not look like our standard form here that I've written. So our goal is to change it. We're going to do that again by completing the square. One little difference though from that last problem, notice we've got numbers. We have lead coefficients out in front of our squared terms. Well, when we want to complete the square, we want to remove those. So the easiest thing to do, because they're both the same, which they always would be in a circle, let's just divide 4 through this whole equation. So let's divide everything by 4 and see what happens. And so I'm going to go ahead and do that. I'm going to divide all of these by 4 and go ahead and group my x's and group my y's like we did in the last problem. So if we do that, 4x squared, so that would become just x squared plus, now if I divide 56x by 4, that would become 14x. Leave myself a little space to complete the square. 4y squared divided by 4, so that would just be y squared. Now minus 48y. So 48 divided by 12, or divided by 4, will give me my 12. And leave myself some space to complete the square. Now 15 divided by 4 is not going to be a nice integer, so that's okay. Let's just leave it as 15 fourths. And like we did with that 64 last example, let's just subtract it over. So let's take it to the other side. It's not helping me complete the square there. Okay, now it's really the same problem we just did. We've got a fraction over here, that's the only difference, but don't be intimidated by that, it's just a number. So let's see what goes in the box here to complete the square. Again, this middle term dictates what's going to happen there. So half of 14 is 7, 7 squared, 49. So let's add 49 to both sides. Half of 12 is 6. 6 squared, 36. So let's add that 36 over there. Okay, now we're really close. This side now we're going to factor nice perfect squares. X plus 7 squared. Again, how do I know that? Well, positive here, so it's going to be positive. 7 plus 7 makes 14. 7 times 7 makes 49. So that's why it'll factor that nice and easy for me. Same thing over here. Now I've got a minus, notice, so it's going to be y minus, and then basically half of 12 is 6, square root of 36, so I know it's a 6. Now these numbers, let's just plug them into a calculator. So I'll show a calculator I like here. I've got a graphing calculator that we'll use a lot in the course as well. I like this one. I can see everything on the screen. So negative, push my fraction button, 15 fourths plus 49 plus 36. And hit enter. And it is 325 fourths. So I'm just going to leave it like that. 325 fourths. So there is the standard form of the equation. Now notice they didn't actually ask me to do that, but really I needed to so I could get the center and radius like they asked. Well, from this form, the center is really easy to identify. I hope we're feeling really good about that. HK, it's built right into my form. So it's negative 7, 6. Remember again, those signs feel like they're backwards. Radius, well the radius, this is r squared, remember. So we want the square root of 325 over 4. I don't think that's going to be a nice number. We could try it in a calculator. I like to give exact values. I'll bring my calculator back. Here's a cool thing about this calculator as well. It'll simplify square roots. So I'm going to do 325 and let's hit enter there. 5 square roots of 13. It's 5 square roots of 13. So 5 square root 13 is the square root of 325. Of course, the square root of 4 is an easy one. That's just 2. So we'll leave that radius as an exact value. If we were going to make a plot or something, I'd just plug it in my calculator and actually get a decimal approximation. But there is example 3 from our circles lesson.